Let n be an element of the set 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. And let p and q be the propositions n is even, and that's p, and q is n is greater than 15. So what we're going to do first off is we're going to write out our truth table. So for n is, oops, so start off by drawing our truth table, and we'll do it for, here we go, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, so that's n there. Now, p and q. So p, n is even, so let's write in the values for that. Well, n is 10, p, that means, and that's an even number, so it's true there. False, 11 is not even, 1 for true, 0 for false, and so on. So we'll do that the whole way down. Okay, now we're going to do it for n greater than 15. So we're 0, 0, false for 0, 0, 0, 0 for n is equal to 15. Now, n is equal to 16, so that's true, so some 1s there. Okay, so that's getting things started off. Now, that's just getting the ball rolling on the question. So we have it sort of set up there for a bit now. So the next part is, draw the truth table for the following statements and find the values for n for which they are true. So, P or not Q. So let's do that one here first. So that we're just going to park that for a while, that previous question. So P, Q, not Q, and P and not Q. So we'll do the truth tables for that first off. So we're starting with P and Q. 0, 1, 0, 1. 0, 0, 1, 1. We always start off like that. Now we're doing not Q, so we'll just put in the negations of Q. So just switch 1s to 0s and 0s to 1s. Now, we are looking at P or not Q here. And in that case, what we're going to do is we're going to compare this one here and this one here. Is there at least one true state there? Is there at least one? Yes, there is. Put in 1 there. This one here and this one here, they're both zeros, so that's a 0. 1 and 1, that gives us 1. 1 and 0, that also gives us 1. Okay. The other one is not P and Q. So we're going to start again here. Let's put a double one there. So not P is, looking at these ones here, 0, 0, 1, 1, that gives us 1, 1, 0, 0. Just negate them. The next thing we're going to do is and Q. So what we're going to do now is compare this one here. We're going to just mark them in green. This one here and this one here. Are they both 1? No. 0 here. Let's look at the next one. 1 and 1. Are they both 1? Yes, they are. So this is not P and Q, just to be clear about that. This one here and this one here, that gives us a 0. And finally, this one here and this one here, that gives us a 0 as well. Okay, so those are the two truth tables that we require. Now, what we're going to do here is actually just make a quick note of that. 1, 0, 1, 1 and 0, 1, 0, 0. Okay, just make a quick note of that because we're about to go back to the previous slide. We have done this part here. Draw up the truth tables for the following statements. Okay, so that's done. So that's the truth tables done. And find the values of n for which they are true. So we have to go back now to our n exercise. Okay, so we're going to use these truth tables in the previous slide. So first off, P and or not Q. Let's rub that out. Let's make a little bit of room here. Let's put a bit of room in here. So we'll just rub that out. So now P or not Q, and the other one is not P and Q. Okay, and let's just recall how, let's just up at the top, let's write in our truth tables. So it was 0, 0, 0, oh no, start again. I'll start again. So P, Q, P and not Q, not P and Q. So again, let's just start off by reminding ourselves what the truth tables were. 0, 1, 0, 1. 0, 0, 1, 1. Just set up the truth tables as normal. And as we said on the last slide, this was 1, 1. No, it was 1, 0, 1, 1. And this was 0, 1, 0, 0. So this one here and this one here. So we're just reusing that now. Okay, so that's right. Now let's go through this now and decide which are true and which are false. So this is P, this is Q, and for 1 and 0, this will give us a 1, and this will give us a 0. This is another 1 and 0 here, so 1 and 0. And finally a 1 and a 0 here. So that's this set pairing here. The next thing we are going to do is, as Q is equal to 0, P is equal to 0, and P is equal to 0, Q is equal to 0. That will give us a 1 and a 1 for 13, 1 and 1. Okay. Now 0 and 0, 1 and 0. Now 1 and 1. 1 and 1 up here, that gives us a 1 here and a 0 here. So 1, 0, 1 and 0. So we're left with 0 and 1. 0 and 1, this grouping here, that would give us a 0 here and a 1 here, 0 here and a 1 here. So that's a good bit of work in that. And find the values of n for which the following are true. So, well, with this side here, we have a 1 here and a 1 here. That's not too obvious that that's a 1. Anyway, that is 17 and 19. Okay. And the rest on the other side for P or not Q, it's everything except 17 or 19. Okay. So the answers are, for this one here, 10, 11, 12, 13, 14, 15, not 16 and 18. And for that one there, let's do that in a different color actually. For this one here, it's 17 and 19. So that's a good bit of work done. Use the truth tables to find a statement that is logically equivalent. So I tell you what, we're going to save that for another presentation. The truth tables with membership tables that's the one we've just done there. So that was long enough.